Okay guys, so this video is hopefully going to cover and clarify how we use scatter plots and lines of best fit. So in this unit, when you're given a scatter plot, you'll be given a graph with a line on it which represents its line of best fit. Okay, we're not calculating the regression line or whatnot like we did earlier. We're just calculating this line off the graph, and it's exactly the same as you've done earlier when you calculated the formula of a line. Okay, so we follow those exact same steps. So I've got on the side here question 1 from 6G3. Okay, straight lines being fitted by eye to a plot of travelling time against distance travelled. Okay, in kilometres for 9 plane trips between different cities. Okay, so somebody's taken some data. So in this case, they've got our 9 points. If I look at 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 plane trips between different cities. Oops. And they've put them on a graph. What they've then done is taken a ruler and tried to find a line that fits between most of those points pretty evenly. Okay, doesn't have to cross through every point. Okay, or else it'll be quite a zigzaggy line. Just trying to find the best approximation. So the first thing we need to do is look here. Okay, so look down on the y-axis. In this case, the y represents time. Okay, some reason they put time on the side, and we want to see where it's hit the axis. So I'll put a little mark there. Once we've done that, we can then calculate the rest of it. Okay, because we're going to use this point here, which is 3,500 and 325. Okay, that's read straight from the graph. Right, I'm just going to move my video because that's not in a very good spot there. Right, so we need to find out what the y-intercept is. Okay, we have to make a bit of a guess here. So we know that this is 25. So 25, 30, 35, 40, 45, 50. I'm probably going to put that at around about 40. Okay. Now, this is where you're allowed to have a little bit of difference between what I get and what you get, as long as it's realistic. If you've gone here and put, that's about 20, then you're probably not going to get marks for that intercept. If you've taken a good guess between 25 and 50 and you've gone for something reasonable, okay, so here if you said 35, 30, something like that, you'd be okay. Okay, I've gone for 40, so my first point's going to be 0, 40. Right. Okay, P1, P2. And we know that once we've done that, we can just find a gradient. So let's have a look at the question now. We've had a quick analysis, found a couple of points. So determine the equation in terms of t and d, give the values of the intercept and slope. Okay, so we've given the value for 40 for the intercept, so we'll just write that here. A equals 40. B equals, so y1, y2 minus y1, 3, 2, 5 minus 40, over x2, 3,500 minus 0. Okay, so this is our B. I'm just going to quickly do a calculation on that, and that equals 0.08. So the final step is to write our equation out. Remember that we're using time. Okay, so time is our y and distance is our x. So we have t. Okay, because this comes from over here. I'll just get my capital T working. So capital T equals A, which is 40, plus 0.08, and if you look over here, it's little d for kilometres. Okay, that's the first step of this problem completed. Okay, so the next step, part of the problem, is to use this equation. So part B, we're saying use the line to predict the travelling time between two cities. Okay, so one city is 2,500 kilometres apart, and the second is 4,500. All we have to do here is substitute these values in as our distance. Okay, so let's do that quickly. Okay, so I just ran through quickly and plugged those numbers in. So as you can see, the 2,500 went in here, whereas replacing the D with 2,500 got me an answer of 240 minutes. Okay, same way, 4,500 got put into the equation and gave me 400 minutes. Okay, so by doing that, we've answered question B. Okay, and we've predicted two travelling times for those two cities which are that far apart. Okay, part C. When making predictions in B, are you interpolating or extrapolating? And this is really important. Okay, so the only thing that tells you whether you're interpolating or extrapolating is whereabouts your distance is. Okay, so in this case, I've got a range of values from around about 400-ish all the way to 3,500. Okay, so we're looking at the bits we're replacing. So this 2,500 and a 4,500. 2,500 comes in here and it goes up. I'll put it on the thing. So that's the first point we're looking at, and it comes up in here. Okay, and that matches around about 240. Okay, and we can see that our formula has worked. So in this case, of course it's inside the values, we can safely say that that is interpolating. Okay, so I'm going to write that in, interpolation. Okay, and the next one, the 4,500, so we end here, 4,500 is going to be up here somewhere, okay? And that is well beyond the values we've recorded in the past, okay, or the values that we've presented. So that, by default, is extrapolating. We're extrapolating from this information where we think it should be. Okay, so just recap of what we just did. First off, we went and found the y-intercept. Okay, then we chose another point to get our point 1 and point 2. We then calculated a gradient. We then put those values into a function, okay, using t and d, which are the values told in the question. After that, we used two values to find out how long a journey would take. Once we did those two values, we could then decide whether we have interpolated a prediction or extrapolated a prediction. So I hope that covers most of what you need to know.